Okay, so in this video here, what I'm going to do is first I'm going to show you the correct way to find an angle using the law of cosines, and then I'm going to show you what happens if you go wrong and you use the law of sines. Okay, so here is the triangle with what I'm given. Okay, and I'm going to label it first. Here I have A, B, and C. A, B, and C, and I'm going to mark what I'm given in red. So A is 5, B is 6, and their included angle is 15 degrees, and so this is a side angle side triangle. Okay, so here I have angle A, angle B, and angle C. Side A, side B, and side C. A is 5, B is 6, C is 15 degrees, and I put boxes around that. Okay, so just like the last problem, the first thing I'm going to do is to find side C. And I'm going to do that with the law of cosines, right? So basically I have, what I'm trying to do is to find this side opposite my two other sides in the included angle. Okay, so I set this up with C squared is equal to 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine of 15 degrees. Okay, so I punch that into my calculator to get C squared, and then I square root that, and I get that C is 1.74. Okay. Okay, so now what I'm going to do is I am going to find angle A the correct way using the law of cosines. Okay, now there's only one answer to this. Okay, using the law of cosines. So here's what we do. So like what we did previously, right? What I do, I now know that C is 1.74. I'm going to put that here. So I have that 5 squared, that's A, is equal to the sum of the other side squared, so 1.74 squared plus 6 squared minus 2 times these two, 1.74 times 6 times the cosine of angle A. So using this, the pattern shortcut thing that I showed you in the first video, I can solve for cosine of A, and that's equal to 5 squared minus 1.74 squared minus 6 squared all over negative 2 times 1.74 times 6. Okay, so when I punch that into my calculator, I get a certain number which I didn't write down, but then when I inverse cosine it to actually get A, I get that A is 47.8, 7, 9, or 8. So this is pretty close to 48, right? And then from there I can solve for B, which is 117.2. Okay, with that in mind, I'm going to show you the wrong way. So this is the wrong way using the law of sines. Okay, so let me backtrack and set up what we're given first. So we have angle A, angle B, and angle C, side A, side B, and side C. And what we're given is that C is 15 degrees, and that side A is 5 and B is 6, right? So this is what we're given. And now we still had to go through this first part here to find that C, which is 1.74. Okay, so you're saying, okay, well I have this ratio here, so I can use the law of sines to find A. Well, I want to show you that if you do what you did to find A using the law of sines correctly, you're going to introduce a second triangle. Okay, so here we go. So if I have sine of 15 over 1.74, well, I should be able to say sine of A over 5, right? Now if I solve for sine of A, I get 5 sine of 15 all over 1.74, and then I do inverse sine both sides, and basically I get that A is 48 degrees, right? And that's about what we got earlier. Now remember, whenever you take inverse sine, you need to find the supplement, okay? You always do this. And so when you do that, the supplement is 131 degrees. Well, let's take a look. This is 131 and I'm given 15. Well, 131 plus 15 is less than 180. That means that we would have a second triangle, okay? But from the law of cosines, we know that that is not true, okay? So this is one way that you could introduce a non-existent solution if you don't stick with the law of cosines, okay? So that's one way, okay? An even worse way you'll see in the next video. Okay, so what I want to emphasize is basically if you start with the law of cosines, I know it's more work than using the law of sines, but use it all the way through so that you get the correct answers, or answer, because with the law of cosines, except for the ambiguous case, there's only one solution.